Hey, welcome back to 6.1D. Please go grab the green cross-cutting concept paper. It'll say scale on it. Today's joke of the day is brought to you by badjokes.com. What do football players and airplanes have in common? Touchdowns. All righty. Today you're going to be drawing some models and writing, so please feel free to pause the video whenever you need to make sure you have time to draw. Scale helps us, and models of scale help us explain concepts or items that are not directly observable, whether they're too small or too large. And we're going to talk about spatial scale, so sizes that are too small and too large as they relate to Earth science. And we'll talk about time scale, time scales that are too short for us to see, or maybe even too long of a time for us to see. So let's go ahead and get started. If you could pause the video and write these 4 red items under spatial scale, that will help greatly. And then unpause when you're finished. All right. So you'll write, you've already written in global, and next to it, you can draw a picture that helps you, the planet, whether it's a sphere or a flat map, but you'll draw something next to the word global on the right of your paper. We can't see the globe. It's not observable to us in one shot where most of us are, unless you're an astronaut. And even if you're an astronaut, you can't see the whole thing. So creating a model that allows us to see such large concepts is helpful. Another spatial scale is region. For example, this is the Grand Canyon. You can draw the Grand Canyon here if you wish, add some color. You can draw the Rocky Mountains. A region is going to be smaller than global, but it's still going to be quite a large area. The next one, observable location, this is going to be where you currently are. So for example, these people here are whitewater rafting in the Grand Canyon, and what's right around them is observable. You could draw this, an observable location. You could also draw, could be a concert, music concert. It could be you at grabbing fast food. It could be you working out in the gym or playing basketball. So whatever you want to draw to help you with an observable location, sorry about that, means that it is where you are. The last one is microscopic. Microscopic we worked on in the beginning of the year. They are concepts or items that are too small to see, and so their size is so small. So using a microscope, using a hand lens, for example, these are sand grains, and you can draw anything from sand grains to bacteria. If you want to look up what a picture of a bacteria looks like, even blood cells, those would all be microscopic. For each of these, hopefully you've added a picture to the left side of your paper. And now we're going to move on after spatial scale to time scale. Time scale, the amount of time over which a phenomenon or process occurs. It's going to be how fast or slow it is. So pause the video and please write all 5 of these time scales and then unpause when you're ready. For this section, you do not have to draw anything. You can just write 1 or 2 words that help you understand it. We'll start our first one with millions
The thing
of
that's
years.
different about a Virgo vacation home?
I guess it's
You always have the
VRVO.
process known as plate tectonics.
And so this is something that occurs over millions of years. You can write the phrase plates moving or plate tectonic theory. And this is something that is not observable to us, so models help it out. Our next type of scale that can happen over years, this example is a river in Peru where over time, it changed course, and it definitely takes a long time. These are satellite images that were taken from above, and over time, it shows how the river slowly changed its course. For some reason, it took a different direction, and it turned from a regular meandering lake into what's called an oxbow. Once again, these are items that we can't see. over time, and that they can't see right away. And so having a scale definitely helps out. Another one, days. You could write a volcanic eruption. This is Kilauea from just January 21st. This has been going on since January 5th, so it's been going on for 16 days. It will continue to erupt until it's finished. This is the beginning of the major eruption on January the 5th. This lava that's exploding out is 164 feet high. That is 16 basketball hoops high. It was pretty large. And so for days, you could write volcanic eruption. For minutes, something that happens so quickly, you can write as an example an avalanche. This avalanche, they do this at ski resorts to make sure there's no loose snow. They'll set a demolition team and explosives. You can see the snow that's coming down here, and this can last for minutes. This green building down here is about the size of our PE wing, so you can get an idea of how much snow this really is as it's coming down. But everybody knew they were planning this, and so they moved everybody out. And this type of scale is something that happens within minutes. The last scale that you can write as an example would be a scale on seconds. What you're about to see is footage from the Loma Prieta earthquake in 1994. All of this took place in the matter of under 30 seconds. They just had different cameras in different places. So first you have a classroom. Unfortunately, items are falling down, a very strong earthquake. In a matter of seconds at the exact same time, these are people inside of a gym during a volleyball game. You can see the glass is moving. You can see people here are trying to get out and move away before items fall. And so for scale, you could write seconds. That's all. Have a wonderful day. Go ahead and mark this off and move on, my friends.